The secret Nikola Tesla knew that Thomas Edison never discovered was that you don't need physical wires touching a rotor to spin a motor. You can rotate an invisible magnetic field through thin air using spatial geometry. While Thomas Edison was burning through millions of dollars trying to force direct current through heavy copper cables using crude mechanical switches that exploded in showers of sparks, Nikola Tesla sat on a park bench in Budapest, picked up a wooden stick, and drew a simple diagram in the dirt that rendered Edison's entire electrical empire obsolete overnight. Edison was trapped in a mechanical mindset. He believed electricity was like water pushing through an iron pipe in a single, straight line, requiring physical carbon brushes to constantly slap against spinning copper parts to keep the current flowing. Tesla saw that nature didn't operate on friction. It operated on waves, resonance, and invisible field geometry. By feeding staggered alternating current waves into stationary coils positioned in a circle, Tesla created a self-sustaining, rotating magnetic vortex in empty space. When a solid piece of metal was placed inside that invisible vortex, it spun continuously at thousands of revolutions per minute with zero friction, zero sparks, zero mechanical brushes, and zero wear. That single geometric insight, the rotating magnetic field, built the modern electrical grid, powered every industrial factory on Earth, and lit up the entire planet. To see why Edison was completely blind to Tesla's discovery, you have to look inside Edison's direct current generator at the exact moment it catches fire. Direct current flows in one constant direction. To generate direct current using a spinning shaft, Edison placed a wire coil inside a fixed magnetic field. But as the coil rotated, the electrical voltage inside the wire naturally reversed direction every 180 degrees. To force that flipping voltage to flow out into the city in a single, straight line, Edison had to attach a mechanical switch called a commutator directly onto the spinning shaft. This commutator relied on hard carbon blocks called brushes that physically dragged against spinning copper segments every microsecond to manually flip the electrical connections. Imagine trying to drive a car down the highway at 70 miles per hour while slamming the transmission from drive into reverse 60 times every single second. The carbon brushes inside Edison's generators created violent, continuous arcs of electrical fire. The physical friction melted copper segments, burned through rubber insulation, and ground the carbon brushes down into black dust within days. Edison had to keep armies of maintenance mechanics working around the clock just to file down ruined switches and scrape melted copper out of his generators. Worst of all, Edison's direct current lost immense power over physical distance. As low-voltage current traveled through copper wires beneath the streets of New York, natural electrical resistance turned the power directly into useless heat energy. To keep light bulbs burning, Edison had to build a massive, dirty, coal-burning power station every 4 blocks. Edison tried to solve the distance limit with brute force, buying thicker copper cables thick as a human arm and burning more coal to force more current through the line. Tesla looked at Edison's thick copper cables and realized Edison was fighting an unwinnable war against basic thermodynamics. Tesla saw that electricity didn't need to push forward like a battering ram. It could oscillate back and forth in a smooth, natural wave, alternating current. Edison believed alternating current was completely useless for powering machinery. Edison argued that if electricity kept reversing its direction 60 times a second, any motor connected to the wire would just jerk violently back and forth on the floor instead of spinning. Edison was right about traditional motors, because traditional motors relied on physical brushes dragging against spinning commutators. Tesla realized that the secret was to stop trying to flip the current inside the moving rotor, and instead use the wave of alternating current to flip the magnetic field outside the rotor. This was Tesla's masterpiece, phase displacement. Instead of sending a single alternating current wave through a wire, Tesla used multiple waves that peaked at slightly different times, a multi-phase system. Tesla arranged stationary electromagnetic coils in a ring around an empty chamber. He connected the first coil to the first wave. As the first wave peaked, its magnetic force reached maximum strength. A fraction of a millisecond later, the second wave peaked in the second coil, shifting the magnetic pull slightly to the right. Then the third wave peaked in the third coil, pulling the magnetic force further around the circle. Imagine a crowd of spectators in a massive sports stadium performing the wave. Not a single person leaves their seat, but by raising and lowering their arms in precise sequence, an invisible wave of energy sweeps rapidly around the entire stadium. Tesla did the exact same thing with pure magnetism. By feeding staggered electrical waves into fixed outer coils, Tesla created a magnetic field that smoothly swept around in a continuous circle inside the motor at thousands of revolutions per minute, without a single moving mechanical part touching the copper wire. Tesla then placed a simple, solid cylinder of iron mounted on an iron axle inside that empty, spinning magnetic vortex. The rotating magnetic field cut through the iron cylinder, inducing microscopic electrical currents inside the metal itself. These induced currents created their own magnetic field, which locked onto the outer rotating field. The iron cylinder began to spin, dragged along by the invisible magnetic wave like a surfer catching an ocean swell. There were no carbon brushes, no mechanical switches, no sparking copper, no friction, and no wearing parts. Tesla had invented the AC induction motor, a machine that converted invisible field geometry into raw mechanical work through empty air. When Tesla built his first working prototype and showed it to fellow engineers, they were terrified. The motor sat completely silent on the wooden table, spinning at blistering speeds without a single spark, brush, or wire physically touching the central shaft. Tesla took his induction motors straight to industrialist George Westinghouse. Westinghouse immediately realized what Edison could not understand. Tesla's multi-phase magnetic field didn't just solve the motor problem, it solved the impossible distance problem that was destroying Edison's direct current business. Because alternating current flows in a wave, its physical properties can be altered using a device with zero moving parts. A transformer. A transformer consists of two separate coils of insulated copper wire wrapped around a shared iron ring with zero electrical connection between the two wires. When high-voltage alternating current flows through the first coil, its constantly expanding and collapsing magnetic field sweeps through the air, cutting across the second coil and inducing a brand new electrical current inside it. If the second coil has 10 times more turns of wire than the first coil, the voltage instantly jumps up by 10 times, while the current drops by 10 times. Tesla realized that to send electricity across hundreds of miles, you didn't need Edison's giant, expensive copper cables. You simply passed the alternating current through a step-up transformer at the power plant, raising the voltage to 50,000 volts while dropping the current down to a tiny trickle. Because heat loss in a wire is caused by current, not voltage, high-voltage power could glide through paper-thin wires across hundreds of miles with almost zero energy loss. Once the electricity arrived at a city, a local step-down transformer reduced the voltage back to safe levels for homes, light bulbs, and induction motors. When Edison realized that Tesla's rotating magnetic field and transformer system made his multi-million-dollar direct current power stations obsolete, he entered a state of absolute panic. Edison launched a ruthless public propaganda campaign to destroy Tesla and Westinghouse. Edison hired local boys in New Jersey to capture stray dogs and cats from city streets. He invited newspaper journalists, city officials, and scientists to his laboratory in West Orange. Edison set up metal sheets connected to high-voltage, alternating current generators and publicly electrocuted the animals on stage, claiming that Tesla's system was far too lethal to be allowed into human homes. When New York State sought a more modern method of executing death row inmates, Edison secretly funded the construction of the world's first electric chair, specifically ensuring it was built using Westinghouse alternating current generators. Edison told the press that condemned prisoners were being Westinghoused, hoping the terrifying association with death would drive the American public away from Tesla's inventions. Tesla ignored Edison's horrific publicity stunts, locked himself in his laboratory, and prepared to demonstrate the physical truth of his magnetic discovery on the largest stage in the world. The battle reached its climax at the 1893 Chicago World's Fair. The fair's organizers announced a contract to light up the entire exposition grounds with hundreds of thousands of electric light bulbs, the largest public electrical project in history. Edison and his company, General Electric, submitted a massive bid to build a direct current system for over $1 million. George Westinghouse and Nikola Tesla submitted a competing bid for half that price, using multi-phase alternating current. Tesla and Westinghouse won the contract. In a fit of rage, Edison blocked Westinghouse from using Edison's patented glass light bulbs, believing that without access to bulbs, Tesla's system would fail. Tesla didn't panic. In a matter of weeks, he designed a brand-new, double-stoppered glass light bulb that bypassed Edison's patents entirely, and built a factory to manufacture them by the thousands. On the opening night of the Chicago World's Fair, President Grover Cleveland pushed a golden switch on the main stage. In less than a millisecond, Tesla's alternating current generators ignited. Over 100,000 glass light bulbs blazed across the fairgrounds simultaneously, turning the pitch-black night sky into a glowing, futuristic metropolis of white light. Millions of visitors stood frozen in awe, witnessing a display of clean, continuous electrical power that Edison had claimed was physically impossible. Inside the fair's Hall of Machinery, Tesla set up a physical demonstration of his secret magnetic principle that captivated the world's top scientists: the egg of Columbus. Tesla placed a smooth, solid brass egg onto a flat, round wooden table. Underneath the wooden table, hidden out of sight, Tesla placed his stationary electromagnetic coils wired for multi-phase alternating current. When Tesla pulled the power lever, the invisible rotating magnetic field passed directly through the wooden table, penetrating the brass egg. As the magnetic vortex began to spin, it induced currents inside the brass metal. The solid brass egg began to rotate on the wood surface, spinning faster and faster. As the rotating magnetic field accelerated, the brass egg stood straight up on its narrow end, spinning rapidly in the center of the table like a living top, without a single human hand, mechanical wire, or physical gear touching it. It was a striking visual proof that invisible geometry operating through empty space could perform massive physical work. The success of the World's Fair destroyed Edison's propaganda campaign, but the final victory of the War of the Currents was won at Niagara Falls. For decades, international engineers had tried to figure out how to harvest the kinetic power of Niagara Falls to run factories across the East Coast. Lord Kelvin, the world's leading physicist, headed an international commission to select the best technology for the project. Edison urged the commission to build a small direct current station that could only send power to factories sitting within 2 miles of the falls. Tesla proposed building massive hydroelectric turbines beneath the riverbed, stepping up the alternating current to thousands of volts and transmitting the energy 26 miles away to light up the city of Buffalo, New York. The commission rejected Edison and awarded the contract to Tesla and Westinghouse. On November 16, 1896, engineers opened the giant sluice gates at Niagara Falls, sending millions of gallons of rushing water crashing down into Tesla's submerged hydro turbines. High-voltage alternating current surged down thin copper wires suspended on wooden poles stretching across the state. 26 miles away in Buffalo, streetcars lurked into motion. Massive industrial machinery whirred to life, and tens of thousands of incandescent lamps lit up homes, offices, and streets simultaneously. It was the first time in human history that a massive natural force had been harnessed, converted into an invisible magnetic wave, and transmitted over long distances to run an entire modern city. General Electric realized that Edison's direct current technology was a complete dead end. The board of directors removed Edison from active management of his own company and licensed Tesla's multi-phase patents to survive. Edison fought the electrical revolution using brute physical force, thicker copper wires, dirty coal stations, and mechanical carbon switches dragging against spinning metal. Nikola Tesla saw that the physical universe didn't run on mechanical contact. It ran on invisible field resonance, phase displacement, and spatial geometry. By mastering the secret of the rotating magnetic field, Tesla eliminated mechanical friction, conquered the limit of distance, and created the silent, invisible engine that powers the modern world.